Hey guys, these are your notes for section 10.2, and we'll be looking specifically at one specific type of sequence in this section, and it's called an arithmetic sequence. It looks like arithmetic. It's spelled like arithmetic, but in this context, it's pronounced arithmetic. So, an arithmetic sequence is when you get each next term by adding a constant number to the term before it. So an arithmetic sequence is found by adding a common difference each time. We're going to call that common difference D for difference. And you can see in my red example up here that I've given you, D would be positive 5. Recursive and explicit forms of an arithmetic sequence. Remember the recursive form, we talked about this a little bit in the last video. Recursive form is kind of cool, but not really the great one to have if I ask you to jump to the 100th term. Because to get each term, you always have to look at the one that came behind it. So, you want a term? Okay, do this math. You want the, fourth term? Look at A sub 3, look at the third term, and add your common difference to that. The explicit form, this allows you to jump to any term you want. You want the 100th term? We can jump to the 100th term. So to get a term, you take the first term plus D, your common difference, times the quantity, n minus 1. What's n? N is the number of term you want. What's A sub n? The term itself. For example, I have all this information in that red formula up there, in that red sequence up there. I have A sub 1, it's 2. I have D, it's 5. What term do you want? Oh, I don't know. Let's do like the fourth one. So you know what would be put right here? 17. 17 is the fourth term. This is 2. This is 5. This, go back here. This was 17. Which term was it? It was the fourth term, n is 4. And if you check it, 17 equals 2 plus 5 times the quantity 4 minus 1. Yeah, it's true. So these kind of go together. This is, which term are we talking about? Which numbered term are we talking about? This one is, now tell me what the term is, okay? So you want the 100th? No problem. You need the first term, you need D, you need to sub in 100 right here for N. Okay, let's look at some examples. Are they arithmetic, yes or no? If they are, what's D? So I see the pattern here, down 4, down 4, down 4. Yes, D is negative 4. May take you a minute, but I think I see the pattern here. Up 0.5, up 0.5, up 0.5. Yes, it's arithmetic. D is 0.5. Some of you not so mathy people are going to be like, yeah, that's arithmetic. You add 1 to the denominator each time. Come on, guys. You can't do that. That's not a thing. You'd have to get common denominators and all that. So this is not arithmetic. And if you don't believe me, take 1/3 minus 1/2 on your calculator and see what this difference is. And then take 1/4 minus 1/3 and see what this difference is. And take 1/5 minus 1/4 and see what this difference is. Might be a good thing to do, to just investigate why I'm saying no. And then, no, that's not arithmetic. Next one. You need to know what these directions mean. Find the nth term. It didn't tell you which one to find. What that means is they want you to write the formula. They want you to write something like this. Write a formula or equation. So make a note on that in your notes. Find the nth term means write a formula or equation. And we're given some information here. So I can see that my first term is 4. I wrote it down. I can see that we're going up 7 each time. D is 7. I wrote it down. we're supposed to write a formula or equation. So this is what it should look like. And I just copied it from up there. This is what it should look like. Sub in what you know. Don't know that. Ah, I know this one. Oh, I know this. Don't know. And that's just -1. Remember, these two kind of go together. Now, do the math. Distribute your 7. Collect like terms. There's your formula. Find the nth term means write a formula or equation for a sub n. We did that. Check. And then jump to the 20th. Well, that's easy now that you've got your explicit formula. Jump to the 20th. I want the 20th term. Here I go. I'm going to take 7 times 20. Remember, n is 20. If I want my 20th term, minus 11. This is my 20th term. This is a sub 20. Another one that's similar, but we're given different information. Find the nth term. You should know what that means. Write a formula or an equation. Again, this is how we're going to get started. Now, it's not quite as easy this time. I do know what a sub 1 is. Just kidding. No, I don't. Just kidding. I don't know what a sub 1 is. I don't know what D is. So I don't have any of this information yet. Let's go over here and write down what we do know. It tells me a sub 5 is 19. Don't know, don't know, don't know. And it tells me a sub 9 is 27. Now, think about this for a minute. I don't have a sub 1. I don't have D. But I do know something was added each time. Something was added each time, right? How many times was it added? 1, 2, 3. 1, 2, 3, 4. It was added 4 times. So, ready? This is going to be kind of cool. 19, which is where we started. 19 plus D plus D plus D plus D gets me what? That's a D. So, these two. Back to this formula. I know now that D is 2, that's going to stay the same. Do we know what a sub 1 is? Well, no, not yet, but I think you can figure it out. If the 5th one is 19, can you back that up 2 and back that up 2 and back that up 2 and back that up 2 to get the first term? I think the first term is 11. So, a sub n equals 11 plus 2n minus 2. A sub n equals 2n plus 9. Okay? Again, it's going to be helpful. Figure out what the question is asking you to do. Write down what you know you want to have. And then see if you've got anything you can sub in, or maybe you don't have anything you can sub in, but there's a way to go and find it based on the information that you're given. Okay. We're going to talk about adding numbers of an arithmetic sequence. But here's the thing. You know how I mentioned in the last video that it is going to be possible to do an infinite sum? It's not possible on an arithmetic sequence. An arithmetic sequence, the numbers either just keep getting bigger because we're adding a positive d each time, or the numbers in my sequence keep getting smaller, negative, because I'm adding a negative number each time. So when we add numbers of a sequence together and they're arithmetic, we have to have a stopping point. And this is how it's going to be worded. It'll say, find the sum of the first 9 terms. So it tells you where to stop. Or, it's worded kind of funny, it'll say, find the 8th partial sum, which means start at 1, stop at 8. So I've highlighted these, and both of these mean we're going to add numbers together, and there's a formula that you're going to use for it. It's a sum formula, so we're going to be using a capital S. The sum of the first, however many you want. The sum of the first 9, that would be a 9, that would be a 9. The sum of the first 8, that would be an 8, that would be an 8. So you got to do however many you want divided by 2. You need your first term and your 8th term or 9th term or however many we're adding together. Okay, so in this first example, it says the first 9 terms. Not real crazy about the way this question is worded because it doesn't tell you, hey, negative 24 is your last one. That is your 9th one. So my bad on that. I'm not really crazy about the way it's worded. This is definitely your first term. Take my word for it. This is your 9th term, okay? So here's my formula that I want to use. S sum of the first 9 equals 9 of them. And again, I'm just going by this. Divided by 2, parentheses, first term plus 9th term. Do the math. Next one. Find the 8th partial sum. Watch how I set it up. I want the sum of the first 8. That's an 8. I need the first term and the 8th term. Okay, it gives me the first term, right? First, second, third. I need 4, 5, 6, 7, 8. You could count. You could count. Obviously, D is 3, right? So you go 5, 8, 11, 14, 17, 20, 23, 26. Sure, you could count. What if I asked for the 81st? What if I wanted you to do what if I needed the 81st term? I don't think you're going to want to count that out. So let me show you how to find this explicitly, not recursively. So here I go. Remember the a sub n equals a sub 1 plus d parentheses n minus 1? If we want the 8th term, we've got to take our first term, d. What's n? 8. 8 is the number of term that I want. So 5 plus 3 times 7, my 8th term is 26. That needs to be a 26 right there. So I rewrote the formula, first term, 8th term, answer. Right? Again, to get the 8th term, we could have counted. I did count, actually. But it might be so far out there on a test that you don't want to count it out, so no big deal. You just use that explicit formula that will be given to you on a test. All these formulas are given to you on a test. Okay. Next one. It's the same type of problem. It's just written differently. Find the sum. Here's where you start. Here's where you stop. Do you see how this could have been worded? Find the sum of the first 10 terms. Or this could say, find the 10th partial sum. They all mean the same thing. And this expression right here is how you get your terms. So, obviously, we want the sum of the first 10. 10 goes there, 10 goes there. We need our first term and we need our 10th term according to the formula. To get our first term, do this math when n is 1. To get your 10th term, do this math for n being 10. First term, 10th term. Sub them in, do the math. Okay, this one's a little tricky. Last one. So, each row of an auditorium, picture it, you got rows in an auditorium. And if most auditoriums are grow bigger the farther back from the stage that they go. So each row behind the first one has 2 more seats than the preceding row. So that means that D is 2. Let that sink in. Fine. Here's ultimately how you have to answer the question. Find the seating capacity. Seating capacity. How many chairs, how many seats are in there? You have to add all the seats in each row. Add all the seats in each row. They grow by 2s. Add all the seats in each row. The front row has 30. Ooh, good information. That's A sub 1. The last row has 108. Oh, good information, but I'm not quite sure how to write it. A sub something. I don't know. I don't know what that is. But it's 108. However many rows there are, the last row has 108 seats in it. Okay? So let's look at the sum formula and let's see what information we have. I need the sum of how many rows? We don't know. We don't know this. We don't know this. That's in the formula. How many are in the first one? I got that. It's 30. How many are in the last one? Oh, I got that. It's 108. This is what I don't know. Go back to that other formula. Go back to the other formula that I showed you. I don't think you need this. Go back here. Remember this? What information do we have? What information do we need? Well, it says pick a term, any term. To get that term, you take your first term. I know that's 30. In fact, let me write it down. That's 30. Plus D. Oh, we know D. D is 2. Now, these two kind of go together, remember? This is what number of a term is it, and this is what is the actual term. So, look back at the information. I have the first term. Do I have another actual term? It's 108. I have a term. It's 108. I'm going to put in 108 right there. What term is it? I don't know. I don't know what term it is. That's the key to the whole problem right there. So, do the math. You can distribute. You can collect terms. You can subtract 28. N is 40. Okay, so since N is 40, that means that the 40th row had 108 seats. The first row had 30. The 40th row had 108 seats. So basically what we're looking for here is the sum of all 40 rows. And I got 276. Okay, those formulas are really going to help you out. Use them, plug in what you know when you can. Good luck.